Good afternoon, guys and girls. This is Mr. Bettis, your Algebra 2 teacher. I'm doing the lesson for today if you weren't in class, so you have some reference. Today we covered Pascal's triangle and binomial expansion. So these are the handwritten notes. We didn't do this in class, but it might help you even if you were in class, just to refresh. Alright, so Pascal's triangle is a set of numbers, as you can see here, that can expand for infinity if we wanted to. But we really only use it up to 6 in class. So if you can see the patterns, you have ones all the way on the outside, and then you start having numbers on the inside. And the pattern is just really addition. You're just adding the two previous numbers to get the next one here. So if I imagine that there's actually zeros on the outside, 0 plus 1 would still be another 1. And 1 plus 3 is 4. And 3 plus 3 is 6, 3 plus 1 is 4, and then we end with 1 again. And we just keep on doing this, right? So we have 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 6 plus 4 is 5, sorry, and then we end with 1, okay? And then one last time. So we get 1, 6, 15, 20, 15, 6, and 1. And like I said, this can go on forever. But Pascal's triangle is the introduction to what we're actually trying to do, and we're trying to do binomial expansion. We're trying to multiply a binomial to any power without having to do a whole bunch of box method, without having to do a whole bunch of distribution and like 5 sets of parentheses and 6 sets of parentheses. We can just do this methodically instead of doing that, which is very tedious. Alright, so binomial expansion uses the same numbers that we just did for Pascal's triangle. And those numbers for Pascal's triangle are actually the leading coefficients of every term. Okay? So if I had the binomial expansion, if this was a plus b to the 0 power, well, anything to the 0 power is 1. So I just have 1 again. Okay? And then if I have, the next one is a plus b to the 1 power, where a plus b to the 1 power is just a plus b. So a plus b, but I'm just going to do it like this, ab, okay? And then the next part is, will actually be plus, yeah. So a plus b is 1. So if a plus b to the 2nd power is really a squared plus 2ab plus b squared. Okay, so the 3rd power would be the same coefficients here, 1, 3, 3, 1. So that would be a to the 3rd plus 3a squared b plus 3ab squared plus b cubed. Okay, and you should start seeing the pattern, okay? So if I had the 1 here, right, all these coefficients, I could technically put a 1 here as well. So that's just like our Pascal's triangle. It's 1, 1, 1. And over here we have 1, 2, 1. And then over here we have 1, 3, 3, 1. So we can see that all of these coefficients, even if I put the ones there, they match my Pascal's triangle. So I already know that this is going to be 1, 4, 6, 4, 1, oops, sorry, 1, okay? It's the same as Pascal's, right? 1, 4, 6, 4, 1. So what's going on with my a and b terms? What's happening with the powers? Well, let's see. It's kind of hard to see here until you get to the 3rd one. What is a doing as I'm reading left to right? Well, this is a3, a2, a, and oa. So my a powers here are going down. And what are my b powers doing? Well, I don't have a b, then I have a b, I have b squared and b3. So my b powers are going up. They're increasing, right? So I can do that. if I have my 4 here, that's my power. That's going to be the first power of a to the 4th. So what happens to my a? My a's are going to go down. So a4, a3, a2, a1, and then no a's, right? And what's happening to my b's? My b's are increasing. So no b. Then I have b. Then I have b2. And then I have b3. And then I have b4 because I messed that up. So, and of course, since this is plus, all of these would be addition signs. Okay? So we can do that until forever. And this is going to get very long and I might run out of room. But we'll do one more, okay? So my coefficients for 5 are going to be the same up here. 1, 5, 10, 10, 5, 1. Try to space this out. 1, 5, 10, 10, 5, 1. What's happening to my a's? My a's are going to decrease, starting with the power that I give it. So this is a5, a4, a3, a2, a1, and then no a's. And do the same thing with the b's, and my b's increase. So no b's, b1, b squared, b cubed, b to the 4th, and b to the 5th, with plus signs in the middle. But you can see that the pattern just is going to continue. I would do 6, but I'll probably run out of room. The last thing I want to say is look at these powers. If this power is 5, what's the total power for this term? 5. What's the total power for this term? Well, 4 and 1 is 4. 4 and 1 is 5. So it equals 5 again. 3 and 2 equals 5. 2 and 3 equals 5. 1 and 4 equals 5. And then 5 is 5, right? And that could be the same even if we look back here. 2 and 1 is 3. 3 is 3. 1 and 2 is 3. 3 is 3, right? And then the last pattern to look at is that if my power is, say, 5, then I should have one more term to it. So what do I mean by terms? Well, my term is, that's a term, that's a term, this is a term, this is a term, this is a term, and this is a term. So I have 1, 2, 3, 4, 5, 6. So I have 6 terms. So I have one more term versus my power. Okay, so that's the introduction. Now let's do some examples.